Okay, I'll try to complete the lecture in with this section. With this session, I will try to complete the lecture. And if I can't, I'll try to shoot another video for 10 minutes maybe. If I would need, I will do that. Let me share my screen. Yeah, I was speaking myself for 2-3 minutes. So I realized this session was ended automatically and I had to have 10 or 15 minutes of break. So let me calculate the confidence interval for this one, for this exercise, this example. Ten to minus 59 times minus 2.30 times 20 square divided by 21 plus 20 square divided by 18. Yeah, the lower bound is I'm mistaken here. Minus 3.37 64 is equal to female minus mu male is equal the upper bound 29 and 9.37 64. Okay, so that's the confidence interval, the result of the confidence interval. The lower bound is minus 3. Since the confidence interval is including the zero value, and automatically if you construct a hypothesis with double-sided hypothesis, you can easily reject the null hypothesis. If the null hypothesis mu female equals mu male against the alternative mu female is not equal to mu male, if this is the hypothesis with alpha and alpha is 0.05, then from the confidence interval, it's easy to test the hypothesis. Since the interval includes the zero value, the null hypothesis, cannot be rejected. It means there is no significant difference between between the mean female speaking and mean male speaking. Okay, that's the interpretation we can make. Let me see. There's no message. Okay, I can keep going. Let's have some exercises. I'm also following another book that I'm teaching in other university for business statistics. So those are some exercises from that book. I'm going to copy some of them and I'll try to share with you those exercises you study yourself. It's just for practicing. So I'm going to copy the first exercise. There it is. And even there's no verbal statement, all you need to do mechanically, just calculate the t statistics, calculate the degree of freedom, and establish the graphical display and give the result of whether you reject the null hypothesis or not. Okay, let me paste the exercise here. Another example. Yeah. Move it down a little. Yep. Okay. Example, another one. Okay. So in this example, you don't need to worry about the verbal statement. Everything is given and it's double-sided. It's constructed as double-sided. Everything is given. X1 bar, X2 bar, S1, S2, and 1 and 2 are given also. And the alpha level of significance is also given 0.05. And we can get directly to the solution easily. And considering that the variances are not equal, yeah. Okay. So we can get directly for the calculation of this statistic, the t calculated statistics, which is x1 bar minus x2 bar, and this is divided by s1 squared divided by n1 plus s2 squared divided by n2. Let's move it here. Okay. Fine. Okay, it's easy. X1 bar is 35. X2 bar is 42.5. So I can write it down, 42.5. This is divided by S1 square. S1 is 5.8 and S2 is 9.3. And it's going to be 5.8 divided, and 1 is 12. And this is a square, of course. And 9.3, the square, that's divided by 14. And this is within the square root. Okay. let's get the result of this one. If I perform the calculation of this, 35 minus 42.5, 5 point square divided by 12 plus 9.3 square divided by 14. And my result is minus 2.50 and 26. Okay. So that's the calculated statistics. And the other thing is you need to get a degree of freedom. Remember the degree of freedom. I'm going to copy the degree of freedom. I don't want to write it back. So this is the degree of freedom. I'll copy it. So just to save time. Yep, this. Okay, this equals this one square. This 5.8 square divided by 12 plus 9.3 square divided by 14. This is within the square bracket. And I have down here 5.8 square divided by 12. And this is divided by 12 minus 1 plus I have here 9.3 square divided by 14. And this is divided by 14 minus 1. Okay, the degree of freedom. Let me determine the degree of freedom. Look, if the variances are equal, the degree of freedom would be 12 plus 14 minus 2, which is going to be 24, and 1 plus and 2 minus 2, that's going to be 24. So as a result, the result from the degree of freedom from this one will be the result will be less than 24. If it is not the case, then I have miscalculation means. Okay, I also forgot here the square here, and I have another square here. Okay. Fine, let's get going with the calculation of this one. 5.8 square divided by 12 plus 9.3 square divided by 14 square. And this one, I'm also forgetting the square here. 5.8 square divided by 12 square divided by 11, of course, plus another one, 9.3 square divided by 14, and the square of this and divided by 13. Okay, according to my calculation, this is 22.0975. Remember, before the break, I have told you that the degree of freedom will always be an integer value because we can't run the degree of freedom for decimal places from the table. So I'll have to round it to the closest integer, which is 22. I'll use 22. So the critical, I have two critical value because alpha level is 0.05. Since the hypothesis is double-sided, since the hypothesis is double-sided, alpha will be split into half. in determining the critical value. So the critical value, one will be on the left with the negative sign, and one will be positive on the right side. You have two rejection area. So the critical would be T22 and 0.05 divided by 2, that is T22 0.025. I'll have to bring this value from the T table. I'll get to the T distribution table. It's right here. Yeah, that's chi-square table. That's a T distribution table. 22, yeah, I have it directly. I shouldn't be worried about the value of this critical, but this degree of freedom. The alpha level is 0.025, so I'll be dealing with the third column. 22, from 22, I'll get to the third column. You see, this is 0.05. So it's going to be 2.074. 2.074. This is going to be 2.074. Okay, let's place it within the graphical display. Yeah, I will place it here. One on the left, one on the right. Yeah, there you go. I have one here. And okay. So this is reject the null in this area. Reject the null. This is 0.025. And this value is minus 2.074. Let me check back. Yes, 2.074. And I have another one here, 2.074 here. And here you will also reject the null hypothesis. Reject the null. And this is also 0.025. So that area where you do not reject the null hypothesis, which is 0.95, do not reject the null. Okay. Fine. The calculated statistic is minus 2.5026, simply falling within the left rejection path. Yeah. Okay. So it will be falling somewhere here. The calculated statistics is minus 2.5026. Minus 2.5026 is falling on the left or within the left rejection area. Then you do reject the null hypothesis. Since the calculated statistics is falling within the left rejection area. The null hypothesis is rejected with 4.45 level of significance. Since the exercise, the example has no verbal statement, that I cannot make any other comment on this exercise, because it's everything is given and the hypotheses are constructed, and we don't know what mu1 and mu2 stand for. We don't know what mu1 is, what type of population is representing. So we can only just write this statement that will be fine for us at the moment. No need for any other explanation. And you can also try to establish the confidence interval, 95% confidence interval yourself, so for practicing construct a 95% confidence interval for 2 mean difference minus mu2 yourself. Okay, we'll get to another exercise from the book as well. It has also no verbal statement. I'll also include you the other exercises to work out yourself. I will be dealing with 11.19 as well, and I'll end up the lecture with those. And I'll ask you to work out the remaining exercises yourself at home for practicing. That will be very useful for you for the examination. You will find it very useful. If you have any difficulty in answering any exercise, you just let me know within the WhatsApp group, maybe. Okay, I have another exercise here, another example. Tell example. This is example. Okay. Shift it right here. Yeah. Okay. I can get straight to the calculation of the t-statistics. So I have it here. I'm gonna copy back this. Yeah. It is. So it's easy to perform such exercise. No difficulty at all. X1 bar, X2 bar. X1 bar is 165 minus, and X2 bar is 172.9. And S1, let me check whether I have a limitation of time. No, it's still more than 10 minutes still to go. But back, okay. S1 is 31.3 square divided by N1, 40, plus S2. This is S2 actually. I'm mistaken here. S1 is 21.5. And S2 is 31.3 square. This is divided by 32. And this is within the square root. Okay. Let me find out the result of this. (165 minus 172.9) within the square root 21.5 square divided by 40 plus 31.3 square divided by 32. Let me see. Yeah, no mistake, I guess. My result is minus 1.2165. Okay. The degree of freedom, I will also be bringing the degree of freedom from where it is. It is, yeah. I'm going to copy this. Yeah. Okay. That's the degree of freedom. Okay, try to get the result done for the degree of freedom. 21.5 square, this is divided by 40, plus 31.3 square divided by 32. Then this is within the square bracket. This is square. 21.5 square divided by 40. This is within bracket, and this is divided by 40 minus 1 plus 31.3 square divided by 32. And this is a square, and this is divided by 32 minus 1. Okay. Okay. Fine. Let's get the degree of freedom, the result of the degree of freedom. Okay. Okay. 21.5 square divided by 40 plus 31.3 square divided by 32 square. 21.5 square divided by 40 square divided by 39 plus 31.3 square divided by 32 square divided by 31. Yeah. My result is 52.8359. So as I told you earlier, I cannot use decimal places for the degree of freedom. I will have to round it to the closest integer, which is 53. I can consider this is 53, and I'll have to, so this is once the alpha level is, the alpha is 0.10, the critical value. So this is right-sided, the critical value would be T 53 and 0.10. That's the value I will be dealing with. So I'll check this value from the T table. There it is. Okay, so this is the T distribution table, and for 0.10, I'll use the first column. And 53, the degree of freedom is 53. And unfortunately, we have 50 and we have 55. And 50 is 1.299 and 53 is 1.297. So you can take the average of those two just to find 53 to approximate the value for 53. I can do that for you. So since it doesn't exist, I will consider this as the table. This does not exist. Yeah. So I will use T 50 0.10 plus T 55 0.10, and I'll divide this by 2 to approximate the result of for T 53. Okay, I know the result for the first one is 1.299 and the other one is 1.297 and divided by 2. Okay, the result would be, I think it will be 1.2985. Approximately, yes. This is the approximation of 53, the degree of freedom. So if I place this value on this, the critical value will be negative because this is left-sided. I was thinking that this is right-sided. No, the alternative hypothesis will tell you that the direction of the side of the hypothesis. So this is left-sided, so it will be negative. I'm mistaken here. I have to fix it. I'll fix this one for you. Bring it here, and this is negative. I'll have a negative sign here. Let me see my time. Oh, I have 6 to 7 minutes. I'll try to complete the lecture. And I'll include you the exercises as well. You can run the exercises yourself. I'll try to be quick as possible. Yep. Here, I'll have this will be within bracket. I'll have negative sign. I'll have this here, another negative sign. This is negative sign. I'm going to move this, and this is going to be negative. Okay, I'll try to include you the graphical display. So so you have one on the left side, 10%. Okay, it's stressful to complete the lecture within this session. Yep, so we have 0.10, 0.10, reject the null. And I have 0.90, do not reject the null. Check the null. Okay, the value minus 1.2985, 985, the critical value. The calculated statistics is minus 1.2165. We'll have bigger. So the calculated statistics might be somewhere here. Yeah, there it is. Minus 1.65. Right. Okay, you can tell that since you calculated with the statistics, which is minus 1.2165 is falling within the non-rejection area. The null hypothesis cannot be rejected. With 0.05 level of significance. Okay, let me see. I still have 2 minutes to go. Yeah, there's no other statement you could make because mu1, we don't know what mu1 and mu2 stands for. So that will be enough for the explanation. And you can also establish a confidence interval for mu1 minus mu2 with 90%. I'm changing now, 90% confidence level. As a homework, and work out the following exercises. Okay, I'll be sharing with you the exercises just a minute later. I will include it within the in the following subsequent pages. You'll have the exercise in the lecture note. I will share with you with Moodle, and I will be also sharing with you those 2 videos I recorded today for the lecture Friday. So on Friday, luckily you don't have to go to school to watch my lecture because I will be out of town, as I told you earlier and last week. So this would be the end of the lecture. So I have less than a minute to hang up to end up the session. Do you have any questions? Shall I just try to break out the lecture, end of the session? Anyway, we have maybe 30 seconds. Kubra, you are the only one left in the room, in the Zoom room. If you have no question, I'm going to end up the session in the lecture.
No question, thank you.
Okay, thank you for your participation and your patience as well.